right, so we've been talking about the geometry of circles, and so far we've talked about angle measures in terms of central angles, which are equal to their arcs, and inscribed angles, which are half their arcs, and then we've talked about segment lengths in really two contexts. Two intersecting chords inside a circle, and then when you have some combination of secants and tangents outside the circle. Any questions about all that stuff? Okay, so today we're going to talk about a special construction. Construction of a tangent line. So you need a ruler and compass. So in order to do this construction, there's an important fact that's true about tangent lines. And the fact is that the tangent line to a circle is perpendicular to the radius drawn to the point of tangency. Okay, so in pictures, like if I have a circle and you have a tangent line, like for example, suppose this is the tangent line right here. That point right there is the point of tangency, the point where the tangent line touches the circle. So what this fact is saying is, if you draw the radius, center of the circle to that point of tangency, that's actually a right angle. Definitely looks like it should be true, right? Like if you picture like the ground, and then a wheel of a car, something like that. Doesn't it make sense that if you draw a line from the center of the wheel straight down to the ground, that's a right angle? Of course it is, right? That's exactly what this is saying. This is a tangent line. The wheel is a circle. And it says that the radius drawn to the point of tangency is perpendicular of the radius. All right. I don't know which end is the front and which end is the back. Does it really matter? No. Okay, so that's the important fact that enables us to do this construction. Okay, so let's just so I mean, if you can imagine, we have constructions already that enable us to construct right angles, right? We have perpendicular bisector of a segment. We have drawing a line that's perpendicular to another line at a particular point that's on the line. We have a construction that enables us to draw a perpendicular to a given line from a point that's not on the line. We have all these constructions. They're all kind of based on the same thing. But you can imagine that one of those or some combination of those is going to be used to do this construction. And you're absolutely right, okay? So here's the way it works. They're going to give you a circle in the center of the circle and a point on the circle, okay? So that's what they're going to be given. So let's do that. So I have a circle. and the center of the circle, identified like that, and a point on the circle, like this point right here. Okay, and let's call that point P or something. Let's call it O. And the directions would say, construct, the tangent line to circle O through point P. So remember, when they say circle O, that means O is the center of the circle, right? So they want you to construct the tangent line to this circle through point P. All right, so here's how it works. Step one is to draw an extended radius through point P, through P. So draw the radius and then just have it go longer than it needs to go. So I'm going to get my ruler and I'm going to draw that line. So I'm going to make it blue instead. So I'm going to start at O and I'm going to go right through P and then just extend it longer than it needs to be. And if you boil this problem down, already it's something we've done before. We've done problems where you have a line and a point that's on the line, and you have to construct a perpendicular through that point. That's all we're going to do now. We're going to do that same construction. Okay, so step two is to draw a circle centered at P. It could be any size circle you want. Okay, so I have my compass here. I'm just going to put the point of the compass at P and open the compass any amount. Now, if you wanted to, you could open it like the same as the radius of the circle. That's okay, but it could be any amount, really. Okay, I'll just make it the same as the circle, but it doesn't necessarily have to be. Okay, so I'm just going to make a, you could make a whole circle, or you could just make an arc. Like I could just make a little piece of it here, and then a little piece of it over here. That's really all I need is those two markings. But if I wanted to, I could make the whole circle. I could just draw a whole circle centered at P. Essentially what you're doing is you're creating this diameter, right? You're creating this diameter of the circle that I just drew, which the perpendicular bisector of that diameter is going to go right through P. So now we're just going to do the perpendicular bisector construction that goes through P. Okay? So step 3 is to construct the perpendicular bisector of the diameter of the circle from step 2. Construct the perpendicular bisector of the diameter of the circle centered at P. All right, so remember the perpendicular bisector construction is you put the point of the compass at one endpoint of the line segment, and you make you open your compass at least halfway, right? At least halfway like that, and you make an arc. I'll do this in a different color. Like I'll do this one for you. So you make an arc like this. Right? Then you just flip your compass around, put your point of your compass at the other end point of the line segment, this, and make the same size arc. Okay. And then lastly, you just connect the intersection points of those two arcs, those two green arcs that I drew. Okay? I'm going to do this green as well. So it's going to be just like this. So I can make that work. So that's it. That green line now is a tangent line to the original circle O. So it's basically the same construction as perpendicular bisector construction with an initial step that's a little bit different. Okay? Let's do it one more time, and then I'll just remind you how the tools on Delta Map work. So start with a circle and its center drawn. I'm going to actually just draw in the center first. I have a starting point to start with. With that. This time, let's say that the point that we're trying to go through is like up here somewhere. Okay, so the steps are draw the extended radius that goes through that point that's on the circle. I have extended radius. Okay. Second is to make a circle that's centered at that at the point that's on the circle, like right here. I'm going to make a circle centered at that point. And this time, I'm just going to make a little arc here, and then wheel my compass around and just make a little arc over here. That's really all I need, is the endpoints where that point on the circle is the center, the midpoint. Then do the perpendicular bisector construction on that little segment I created. I have an arc going this way. Put my compass around. I have an arc going this way. And then just draw my tangent line. And I'm done. Any questions on that? Let's just do one real quickly on Delta Math so you can remember how those tools work. Here, I'll find it. There it is. All right, so here's a typical problem on tonight's homework. Just like what we just did, right? It says use compass and shade to construct a tangent line to the given circle at point U. Right here. Your final answer should be exactly one blue line. Okay, so the process is first draw the extended radius. Now, if you wanted to, you could make this a segment or array or a line. It really doesn't matter, okay? I'll make it a segment, but it doesn't really matter. Actually, no, this one actually has to be array or a line because it has to, you have to actually start at this point and make sure it includes that point. So I'm going to have it be a line. So you start at that point and have it go through you. Okay, it doesn't necessarily have to be a radius. It could be a diameter like I have here, okay? Or array, it doesn't matter. Second, I'm going to draw a circle that's centered at you. So compass. You put the point of your compass at U, and then open it any amount. Okay, I can open it any amount. I'll open it this time not equal to the radius of the original circle. I'll have it be different. And then remember, you have to actually use the pencil of the compass to make a mark on one side and then on the other side. You can do the whole thing if you wanted to, but not necessary, right? What I have so far. And then I'm going to put the point of my compass at one end point, open the compass more than halfway, this way, more than halfway, make an arc, keep the compass the same radius, move it over to the other side, and make an arc. And you can see I have everything I need now. I just need to finish it off. Now, this is where it kind of matters what you use. It says your final answer should be one blue line. If you made this a segment, they're not going to give you credit for it, which is stupid. They should, right? But it needs to be a line, so let's just have it be a line from here to there, and we're done. Multiple points clustered very close together where you made your line. Okay. Oh, it doesn't matter? I don't know why they even let it on. Okay. So submit answer, and that's it. Okay? And you can watch their little animation too. I mean, they give it to you step by step here. You just keep doing it. See, they're doing the same thing. They have slightly less markings because really you don't need this entire arc that goes all the way down like this because you actually have another point to go by, the point that's on the circle. So you don't really need all these markings, but better to have more markings than you need than too few markings, I think. So that's it. Any questions? So the homework is just do a few of those. That's all I got. Okay.